Now, let's look at this question, which comes from the Cambridge International Advanced Subsidiary and Advanced Level. And the paper is 9709/11, Pure Mathematics 1, paper 1. So the paper was taken November 2023. And we are considering the topic of functions. So that particular question we see tested in question 4. Yes, yeah. So the transformation R denotes a reflection in the x-axis, and the transformation T denotes a translation of 3, -1. Find the equation y is equal to g of x of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations R followed by T. That means we start apply transformation R on y is equal to x squared, after which we apply T. But we have seen that T is a translation. Actually R denotes a reflection in the x-axis, and T denotes a translation of this. So in this case, it means that first what we'll do, we'll first apply a reflection, then follow it with a translation. Fine. So part A, that's 2 marks. Part B, find the equation y is equal to h of x of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations T followed by R. 2 marks. Then state fully the transformation that maps the curve y is equal to gx onto the curve y is equal to h of x. So we should see that we have already worked out. By the time you reach to part C, you should have worked out this y is equal to gx and y is equal to hx, so that by inspection of the two functions, you are able to see the kind of transformation that has applied on this to get this. That's 2 marks. So that's the question, and let's see what the solution looks like. Well, let's look at this. We are told that a transformation R denotes a reflection in the x-axis. So R is a reflection in the x-axis. So transformation R is a reflection in the x-axis. In the x-axis, yes. And the transformation T is a translation 3, -1. That is adding 3 to the x coordinate and subtracting 1 from y. Then we are told, find the equation y is equal to g of x, y is equal to g of x, of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformations R followed by, first it is R followed by T. First, so we apply R on this. So we first, having drawn the line y is equal to x squared, we first reflect it along the x-axis. After reflecting it along the x-axis, the image that we find, we apply transformation T on it. So we say a reflection in the x-axis changes the sign of the y coordinates, because if you have this to be the x-axis and this is the y-axis, and this x-axis is acting as the mirror line. The x-axis is acting as the mirror line. So it means that if you are to draw y is equal to x squared, if the curve, I'm saying if the curve, because that should mean that as y increase, x is increasing astronomically. So if this is the line, if this may be the line, then when you reflect it on the x-axis, it will be something like this. Yes, it will be something like that. It will be something like that. So that this is the mirror line. So this one is reflected here. So that changes the y. You see, by reflecting it here, it means that the y values are changing from positive to negative. So we say a reflection in the x-axis changes the sign of the y coordinate. So the equation y is equal to x squared becomes, so for this now, if this is y is equal to x squared, this one now becomes y is equal to minus x squared. So that's what we are saying, minus x squared. So that is the first thing. So we see that it has changed from this to this. Now we apply the translation on this. So we say translation by 3,1 moves the graph by shifting x by 3. Shifts it by 3. It's adding 3 to x. It's adding 3 to x and subtracting and y by -1 and reducing y by -1. So effectively, what that gives me is that if the equation I have is y is equal to minus x squared as such, then by incorporating this fact and this fact, I will then have where there's x, I have to put 3. Where there is x, I will have to put 3. So if that's the case, then what I end up with here is y is equal to minus x minus 3 squared minus 1. It becomes y is equal to minus x into minus 3 squared minus 1. So if you consider this now becomes the new image, the image of this now becomes the image of this. So we started from this equation, then this reflection brought it here, and once it's here, we again picked it with the same translation here. So that translation has had the effect of, because now we have y is equals to minus x squared, so it means that the y, in this case, we have minus just remains, but now it's not, it's actually, it should be x squared, but now we are subtracting 3 from it. So we put, because it's down, it's lower. Adding that we've actually said somewhere that translation by 3 -1 moves the graph by shifting x by +3 and y by -1. But tell us that implies to the bottom of the curve where y values are negative. So effectively we have this, and so this is this. So our gx that is asked is actually minus of x minus 3 squared minus 1. Then part B, find the equation of y is equal to hx of the curve with the equation y is equal to x squared after it has been transformed by the sequence of transformation t followed by r. T followed by r. So if I rub this, I should be having, first we apply the translation to the curve y squared. So we have y is equal to x squared. So we apply the translation, this translation to it. So by shifting, we shift x by +3 and y by -1, just the same thing we did. Then the equation becomes, because we are shifting it, it's a translation. You see, first apply the translation to the curve y is equal to x squared, shifting x, yeah. So it means that what we are having first, the first instance will just be this, where, because here we had y is equal to x squared, and because of the reflection, but here we first apply the translation. So we would say the equation becomes, in this case, it's just this, y is just minus of x minus 3 squared minus 1. That's the effect of the first translation, this translation here. Then second, we want to consider a reflection. So first, we have applied the translation, which leaves us here, because this translation, we have seen that it takes, this translation, if applied, that is what gives us here, because where there's x, having x squared, where there's x, we subtract 3 first, then square it. Then the second thing that we see is now we look at the reflection. Now we consider the reflection, and the reflection will be, so we'll be reflecting this. We'll be reflecting this. We'll be reflecting the translation. And we had seen that reflecting the translation has the effect of changing the sign. So it means that this is going to be change to be y is equal to, because we change the sign of, it is the sign of y that should change. The translation, as we had seen, changes the sign of y. So it means that we are going to have y is equal to minus x minus 3 squared plus 1. So that is h of x. That implies that h of x, the image now, after performing a series of those transformations, now becomes minus of x minus 3 squared plus 1 as such. That's the equation of the curve, is that. Then part C, state fully the transformation that maps the curve y is equal to gx onto the curve y is equal to hx. So we need to translate, we need to state fully the transformation that maps this onto this. A transformation that maps this particular function into this function. So let's see. The difference here has to be seen in this and this. And then what is that? So we say that this can be mapped to this by a vertical translation of 2 units. By a vertical translation of 2 units. Why 2 units? It's 2 units because if we had this, and for some reason, let me say our curve now looks like this. Let me say our curve looks like this. And we see that was it. And then now, so this now, this is this. So we say this perhaps is this. Okay, this is this. So I say this is, say, minus x plus 3 squared plus 1. But there was another one here. There was one here. Here. That is just the same curve. It's a similar curve, but now it's below, so that it has this. So for us to move, it means that it's a vertical translation in this sense, vertical translation. And that difference, if this is minus x plus 3 squared minus 1, then for me to move along the y-axis, I'll come from -1 to 0 first, that is 1 unit, and then from 1 to +1, those are 2 units. So I say y is equal to g of x, which is this, can be mapped to h of x, which is this, by a vertical translation. This is the vertical translation. Since the difference between the two equations is the change in the constant from -1 to +1, this. So that's why we are saying the change is 2 units. So vertical translation of 2 units up leaves us with a transformation of. So if we look at that translation, if it is vertical, it means that the x is not changing. X is not changing, but y is changing by 2 units. So that translation is 0, 2 as such, and that's the answer. So we meet in my next video.